Good morning, students. In this part of the dynamics, actually work for energy, but according to the textbook this is a separate topic, but I divided the topics into different categories. Friction is also part of the dynamics only given in your textbook, but I changed that to separate topic, friction. But after this we will discuss work for energy, collisions, friction, separate we discuss. This work power energy problems I am working directly because you know the formula, simple cases for the work is equals to force into displacement, F dot S is equals to Fs cos theta. In the vector form we can take if the theta is 0, cos 0 is 1, maximum work is done. If theta is 180, opposite direction, force and displacement opposite direction means the work done is negative. If you are lifting the object upwards from the ground, the minimum force you have to apply upward direction is nothing but equal to its weight, that is going to be F equal to mg. The displacement itself is h. Moving upward direction means theta is 0, same direction, force is upper, displacement is upper. So F and S same direction, theta 0 we take, cos 0 is 1, work done is maximum, that is equals to mg into h. What is the work done by the earth for attraction? Then gravity force is downwards, weight only gravity force. Mg is downwards, but the displacement is upwards, theta is 180 degrees. If the displacement is up, but the weight is acting downwards, the theta is going to be 180 degrees. Force is up equal to mg, force is upward directions, but mg is acting downward. Moving upward direction, the displacement is upward directions. So force and displacement upward direction means theta is 180 degrees. When theta is between more than 90 and less than 270, in between these two angles, cos theta values are negative. And if you take the frictional force, if the object is dragged, not rolling cases, if the object is dragged, object is moving forward direction, that is a sliding friction. Object is moving forward direction, the frictional force opposes that, that is nothing but in the opposite direction to the displacement. The theta is going to be 180 degrees. So frictional force work done is negative you will get for the sliding objects. In the vector form, what we take is variable conditions. If they are given variable force, W equal to integration of F into dx. You can take dx is a small displacement and the integration limits that depending on the expressions given we need to calculate for this work done. And area of the force displacement graph, if they ask force and displacement graph, area means what you get is area equal to force and displacement, which is nothing but equal to work and energy. Energy is the physical quantity which is required to do any work. So energy appear in different forms, but work and energy are same only. Power is nothing but equal to work by time. What we take is power equal to work by time. The rate of doing power, the rate of doing work is called as a power. Work units are joules and energy equivalent to work itself, but energy has a different practical units. SI units are joules only, practical units are there, calories are there, electron volts are there, and the electrical unit energy is nothing but kilowatt hours are there, different units are there for energy. And work unit is joules, SI unit, and power unit is watt, joule per second is equals to watt. And if you are doing the work to lift any object, if you want to lift any object like this object, if you want to lift it up, it's not a point body, then in that cases work done is nothing but equal to work done to lift the object, big objects or extended body is equal to lifting its center of mass. So if I am making this object lifted up, it is horizontal, I made it straight up. What is the work done is nothing but equal to mgh. Total height is, say length is L, the height you have to take is equals to the distance from the bottom from from where it is lifted to the center of mass or center of gravity point of the object. For the uniform symmetrical body, the center of gravity will be exactly at the midpoint. So that lifting whole body is equals to lifting its center of gravity. This point is not lifted at all, this point is lifted by the maximum height. So average height is nothing but equal to related to center of gravity. What is the work done to fill up the tank? Or what is the potential energy of the water in the tank? Work done itself is converted into change in kinetic energy, or work done is also equal to change in potential energy. If you are filling the tank to the height h, then work is nothing but equal to mgh. What height you have to take is nothing but equal to total height is h is given as, don't take this h here, center of mass will be half only. So work done to fill up the tank of height h is nothing but equal to mass of the water into g into h by 2 you have to take, don't take total height. And what about the mass of the water? They may give mass or they may give volumes. H, length, breadth and height. Length, breadth and height they are given means volume will get mass equal to volume into density. Volume into density into G into H by 2. What is the density of the water? They won't give. Sometimes they give, sometimes they don't give. Density of water is nothing but equal to 10 to the power of 3 kg per cubic meters or 1 gram per cc. It is actually at 4 degrees centigrade due to anomalous expansion. The density is not constant for the water with small changes of temperature is around 4 degrees centigrade, more than and less than. At 4 degrees centigrade only water has a maximum density, minimum volume and maximum density at 4 degrees centigrade. This is 4 degrees centigrade, volume is minimum and density graph is reversed. You will get this part will be repeated in the fluids topic later. Next, come back to these numericals. These topic problems are most of them are very simple one only, and symbolic problems are given with the symbols, means those problems are important also and will be asked repeatedly. Body of mass 5 kg is moved up over 10 meters on inclined surface of inclination 30 degrees with the horizontal. Find the work done. They are given this angle with respect to horizontal inclined surface, object is pushed. They may give height h. Whatever work is nothing but equal to potential energy. What are equal to potential energy? If the height is given, directly can go for mgh, means potential energy equal to mgh we can take. But you are given the length here and theta is given, then you have to take the help of sin theta. Sin theta is equals to h by L. The length of slope is nothing but equal to 10 meters. Mass is 5 kg, angle is 30 degrees. G is given for you as 10 SI units. Then work done is nothing but equal to, find work done. Work is nothing but equal to mgh, mg into h. Sin theta is equals to h by L. So h is equals to L sin theta replacement. Substitute the values. Mass 5, G 10, L is also 10 and sin 30. Sin 30 is 1 by 2. This 500 by 2 is 250 joules. Next problem is in the vector form it is given. Force is 6I plus 8J newtons. Displace the object 4 meters along the x-axis and 6 meters along the y-axis. 4 meters along the x-axis, 6 meters along the y-axis. What is the work done? Work equal to F dot S in vector relationship if they give in terms of the components. If they give the magnitudes and theta, W equal to Fs cos theta you have to take. Here displacement, how do you get the relation is 4I along the x-axis, 4 units, along the y-axis 6 units, means 4I plus 6j is the displacement. So work equal to F dot S relation, and the dot product what you get is only I dot I, J dot J remains, so remaining will be cancelled. I dot J is cancelled, 90 degrees, 0 degrees only you will get I dot I and J dot J remains. So directly you have to take 6 into 4, 8 into 6, 24 minus 48 is minus 24 joules, negative work. Next, sixth question, lawn roller. In this lawn roller is the one which is having the heavy cylinder which is pulled on the lawn to level the grounds for the sports purpose or for the level purposing only that is used. It is pulled at an angle theta with respect to horizontal by applying the force F. In this angle direction it is pulled. Then the displacement is on the ground only, horizontally that is nothing but equal to S. Resolve the force into components, but you have to be careful with the angle given with respect to horizontal or with vertical. They gave the angle to 6 degrees with vertical they have given. Don't use this, you have to use the angle with respect to horizontal if you are using the direct formulas. So F applied E is equals to 200 newtons. 200 newtons is not doing the work to displace it on the level ground. Its component in this direction only doing the work. That component of the force F along the S is nothing but equal to F cos theta. So W equal to F dot S equal to Fs cos theta is the formula. Theta, which theta you have to use? Don't use this vertical one, you have to use the horizontal theta, that is the 30 degrees, totally 690, so this 60 means this 30, cos 30 you have to use, sorry. W equal to S is 20 meters displacement on the level ground, with vertical that is given as 60 degrees, so horizontal angle is 30 degrees. W equal to Fs into cos 60, not cos 60, sorry, it is supposed to be cos 30 with respect to horizontal only you have to do. This is nothing but equal to 200 into 20 into cos 30 is root 3 by 2, this is going to be 10, you will get A is equals to 2000 root 3 joules. You can write it as a 2 root 3 kilojoules also. Next point, 8th one, this is very important ones. A chain hanging over the table, chain is hanging over the table, L is the total length of the chain and total mass may be given as a capital M, and a small portion is hanging downward, that is X, they may give it as a L symbol also. and the small mass, that remaining hanging mass, is nothing but equal to m prime. Hanging mass, hanging part mass is equals to small m. Hanging length is nothing but equal to x. Work done to lift that hanging portion onto the table. If you are pulling this frictionless table, they mentioned, means friction, work done against the friction is not there. Work is done, only lift it upwards. But you are lifting the whole hanging portion is nothing but equal to lifting its center of mass. The center of mass will be exactly midpoint. You are taking the symmetrical chain or rope, then center of mass, total x length is x, means what you are lifting is nothing but equal to x by 2. You have to take this point, is important for us. Work done to lift the hanging parts onto the table is equals to how much? You have to find out. Mass is proportional to total mass is proportional to total length. Small mass hanging portion is proportional to x. But here in this problem, we are given the total mass itself as a small m, so that you have to be careful. Just use a small m only. This part is not required, only for explanation I gave you. The lifting hanging chain is equals to lifting its center of mass by height equal to x by 2, because x is hanging downwards. They will give you the fraction hanging. What is hanging part is nothing but equal to half portion they mentioned. Half x hanging length is nothing but equal to total length by 2. This is given as L by n. Hanging mass is nothing but total mass by n, and n is becomes equal to 2 for us. 1 by nth part is hanging, means 1 by 2 part is hanging. Of the total length, half portion is downwards. So work done is nothing but equal to that mass hanging into g into that center of mass shifted upwards is nothing but equal to h. H is nothing but equal to x by 2. This only you have to be careful. Then m prime is equals to m by n, 1 by nth of the total mass. G into x is nothing but equal to 1 by nth of the total length, L by n. But 2 is also there, n into n is L square to mgl by n square. They will ask you the symbols only, please. You have to remember this formula directly, don't go for all this. 1 by nth portion is, or half portion like that hanging portion if they mentioned, directly go for mgl by 2n square is a formula. But in this case what they mentioned is n equal to 2, half portion, half length is hanging downwards. So 2 into 2 square is 4, 4 into 2 is 8, mgl by 8 is the answer. Next question, 15th ones. Cylinder is on the ground horizontally kept. Cylinder is horizontal on the ground. Work done to make it stand vertically. You have to make it stand vertically like this. It is horizontal and making vertically. What is the work done? When it is horizontal, the center of mass is not on the ground, it is at some height is there. What is height equal to radius? Total diameter is r, 2r. So radius is the height you have to take, that is equals to initial height of its mass. The mass is at center of mass only. The center of mass is, height is nothing but equal to h1 first. Next you are making it vertical. Vertical length is L. The center of mass will be at a height from the ground is equals to L by 2. That is h2 equal to L by 2. So work done is nothing but equal to change in potential energy here, that is equals to mgh2 final minus initial. mgh2 minus mgh1. mg into L by 2 minus mgh1 means mgr. mg L by 2 minus mgr. Sometimes they will ask you after taking this LCM. You check up that. Next, 22nd question. Spring compressed by 4 centimeters has potential energy equal to 2 joules. When what is the force required to extend it by 8 centimeters? Two different cases. First case is compression, second case is expansion. But compression and expansion formulas are same only. But here values are given different. Expansion, compressed spring or expanded spring, energy stored in that is potential energy. Whatever work you are doing is stored as the potential energy. The formula for the potential energy work done to compress the spring by the distance x is equals to half k x square. This x1 first case is given as equals to 4 centimeters. Second case we are taking it is equals to 8 centimeters. But second case they asked is for the force. From the first force you have to find the value of k. What is k? K is called as a spring constant, stiffness constant, or also called as a force constant. More is the value of the k, more hard to compress the spring or expand the spring. So it is also called as a stiffness constant. And k units are F equal to kx formula, basic formula for this. So k is the units of force by distance, means Newton per meter is the unit of k. If you are taking the external force applied, F equal to plus kx. If the internal force is there which is trying to expand the spring back to the previous position, you take it as the internal force means minus, external force is plus you have to take. Potential energy given is 2 joules and half k into x1 square. x1 is nothing but equal to 4 centimeters converted to meters, 4 into 10 to the power minus 2 meters square you are getting it. So this is a 2 into 2 is 4 equal to k into 4 square is 16, 10 to the power of 2 minus 2 square is nothing but equal to minus 4 you have. So k we want to find out, k is equals to 4 by 16, 10 to the power of minus 4, take it to the numerator, it becomes equal to 10 to the power of plus 4. The result is 2500 Newton per meter is the value of k. And second part, they are asked to find out the force required to expand it by x2 length. x2 is nothing but equal to 8 centimeters, 8 to the power of minus 2 meters. So external force is, so plus only we can take k into x2. K is 2500 into x2 is 8 to the power of minus 2, which is 200 newtons. Next problem, number 34. A boy weighing 600 newtons. Careful with this. Weighing units may be given kgs or in newtons. Newtons means directly it is given as mg. Kgs means they give only mass. Kg weight also means mass only given. Run up. He is running up. Upstairs of run up stairs of height 10 meters in 12 seconds. He is going up the stairs of height given here. Inclination length is not given, height is 10 meters they are given, and time is given 12 seconds. Find the power, average power. Power equal to work by time. Here work is done equal to potential energy converted. Work done is equal to potential energy. Potential energy is nothing but equal to mgh. According to the requirement, work done can be taken as a change in potential energy or change in kinetic energy. Here work done is equal to change in potential energy from the ground to the height h lifted his own body. If they give sometimes he is carrying some load, then you have to take his mass plus extra load mass, m plus m into gh, total mass you have to take into gh is a potential energy conversion or work done we have to take. Sometimes they will give you steps, each number of steps, each step height they will give, width not required, height only required. Total height is nothing but equal to, h is nothing but equal to number of steps into height of each step you have to take. Work done is equals to mgh here, power is nothing but equal to work by time, mgh by t, but time is directly given in seconds, sometimes they will give in minutes, no, convert into seconds. So mass mg directly given, mg itself is 600 into height is 10 meters by time is 12 seconds. So 6 2s are 6 1s are, you will get equal to 500 watts or half kilowatt. Next pump, motor pump efficiency. These efficiency problems are very important ones. Motor pump efficiency eta is equal to 80% is given. It lifts 800 liters of water. Efficiency 80%, liters lifting is 800 liters. In the time 19.6, overhead means to the height, some height. Overhead tank means at some height tank you are putting. Height is 20 meters. Find the input power. Means input power from the electricity or electric power input you have to find out. All the electric power is not converted into work done. Why? Because of the friction and because the motor getting heated up. Here pump is different from motor. Electricity is given to the motor and motor axle rotates the pump. Pump competence the blades which has due to the centrifugal force it pushes the water out. Now in this case the efficiency is nothing but equal to efficiency formula is always output by input. This is output power by input power in this case. Output power by input power is 80%. Per cent means per 100. Cent is French word means per 100. So 80 by 100 is 0.8 is the efficiency you will get. Then 1 liter of water. For the water, 1 liter equal to, 1 liquid, liter is the unit of volume, 1 liter equal to 10 to the power of minus 3 cubic meters. But if you take the water specifically, density of water is 1 gram per cc or 1000 kg per cubic meters. That reason 1 liter of water, 1 liter of water has approximately weight equal to 1 kg. That is at 4 degrees centigrade, but generally we take it room temperature also, same value, 1 liter is equals to 1 kg. So density is equals to, if it is not water, no, you have to take the corresponding density of the liquid given means density equal to mass by volume relation you have to take. So in this case 1 liter equal to 1 kg, so mass directly you are getting 800 liters means this equals to 800 kg of water. Mass is 800 kg and height lifting is 20 meters, G is 9.8 S units, not given, you have to use 9.8. Efficiency equal to power output by power input. So we want power input equal to power output by eta. Eta is the efficiency, mgh by eta into t denominator. Substitute the values, you will get the answer as 10,000 watts. Power SI unit is watts, that is equals to 10 kilowatts. Next, this 215th problem. This is very very important problem and it can be asked in the different ways in this one problem. But its formula is same. Here you are asked to find the velocity of the bullet. Sometimes they will ask you the powers or mass of the bullets. In machine gun, ordinary gun is that single bullet is fired is ordinary guns, but machine gun means at a time continuously one after the other you can fire the bullets. How many bullets fired is 240 bullets fired in 1 minute. Number of bullets per second, if they ask n by t you have to find out. Time is given per minute means convert into seconds. 60 second, 1 minute is 60 second, number of bullets is 240. Each bullet mass is 10 grams, means 1 gram is 10 to the power minus 3 kg. 10 into 10 to the power minus 3 kg. Power of the gun is given as 7.2 kilowatt. 7.2 into 10 to the power of 3 watts. What is the velocity of the bullet? Here work done is converted into change in kinetic energy. Work done is equals to change in kinetic energy. Initial velocity is 0, so we are taking directly kinetic energy, change in kinetic energy equal to final kinetic energy only, that is half mv square. Because bullets initially at rest coming to get the final speed. And in this case of the firing the bullets, force is internal force, momentum is conserved, but kinetic energy is not conserved. Momentum is conserved means bullet bomb momentum is nothing but equal to gun momentum in the opposite directions. Power equal to work by time means kinetic energy by T, but number of bullets, don't forget the number of bullets, total kinetic energy you have to take change kinetic energy for n bullets into n you have to take. Equating for this v square equal to 2tp by m into n, you will have, substituting these values, you will get v square to 36,000, our velocity is 600 meter per second, each bullet it is, each bullet speed. Next, 109th question. Electric power, electric motor efficiency. This is a motor, electric power. This is a electric power input. Electric power input has the efficiency, that motor has the electric power motor has the efficiency eta 1, and that is rotating the pump. This is a pump. Pump efficiency is nothing but equal to eta 2 mentioned. What is the total efficiency? So between these two, power input, electric power input and power output, between these two efficiencies eta 1, and between the motor and pump efficiency is eta 2. Efficiency is output by input. Finally this output from the coming from the water, that sometimes they will give you this interlinking with the height lifted or pushing the water with some velocity. If the water is coming, velocity also given means you take the kinetic energy of the water plus potential energy, total is nothing by time is equals to output power. You take it. Output power is PO2 by input power is PO1 here, and that is eta 2. Eta 2 is this mgh whatever you take by T, and by input power of this motor. For the motor, what is efficiency? Eta 1 is equals to this output power PO1 by electric power input is P input. So total efficiency is nothing but equal to what you get here is eta 1 8 by eta 2. Actually this PO2 by P in, if you take, you will get this efficiency, total efficiency as the multiplication when you take it. Any number you take a series missions, total efficiency is eta 1 into eta 2. Efficiency won't increase, but it decreases here. Overall efficiency will be reduced only. 80% into 90% is nothing but equal to 0.72 or 72% it becomes. If they ask you input power and given and output power, what is mgh etc. height lifted means this efficiency equal to output power by input power. This total efficiency is nothing but equal to P out by P in. Power output can be converted into kinetic energy or kinetic energy plus potential energy, or only potential energy means mgh. Next 119 question number. Momentum of the object is increased by 50%. Increased by 50%. Increased to means final value. Increased by means change in values. Find a percentage increase in the kinetic energy. Relation to the kinetic energy momentum is kinetic energy equal to P square by 2m. For the first case, initial value Ke1 equal to P1 square by 2m. Same object, so mass do not change. Kinetic energy 2 equal to P2 square by 2m. And you are told that momentum is increased by 50%, means in final momentum equal to initial momentum already there, after that they are increased by 50%. 50% of P1. 50% means 50 by 100 of P1, that is 1.5 P1. Directly you must be able to write this. 50% increase means 1.5 P1. And 100% increase means doubled. Decreased means minus you have to take. Means 50% means equal to 0.5 only comes. Decrease means minus, here increase means plus. Next, taking the ratio of these two. Taking the ratio of these two, kinetic energy final by initial, you will get this as P2 by P1 whole square, cancels, and what is that relation is P2 by P1. You have to, from here also you have to substitute, you will get 1.5 square, which is 1.5 you can write as a 15 by 10. 15 square is 225 by 10 square is nothing but equal to 100. 225 by 100 is 2.25. Directly you can take like this, or 225 also you can take, that is left to your choice. Next, percentage change in the kinetic energy. Percent change in the kinetic energy is nothing but equal to change in values by initial value. Increase taking place means numerical, directly proportional means increases. Increases means you can directly jump to this formula. Change in kinetic energy, the ratio final by initial minus 1. Change in kinetic energy by initial kinetic energy into 100% is the formula we have for percentage change in the kinetic energy. Final minus initial by initial. In case if it is giving increase means final minus initial in the numerator. Decrease means initial minus final in the numerator. But denominator must be always initial value into 100. So this LCM top part if right now K2 by final by initial minus 1 into 100. The result is If it is increasing, decreasing means 1 minus comes, 1 minus Ke2 by Ke1 you have to take, decreased means. Here increase taken minus 1. So minus 1 subtracted and 2.25 minus 1 is 1.25. 1.25 into 100 is 125% is the increase in the kinetic energy. This related problems also they will ask you kinetic energy momentum. If kinetic energy equal to, if you take momentum equal to, if you take momentum is nothing but equal to 2m into kinetic energy. If kinetic energy doubled, what happened to the momentum? Increased percentages also in the same way. Kinetic energy if they give momentum percentage also you must be able to find out. If the momentum is doubled, means it becomes equal to 4 times. Kinetic energy increases by 4 times. K2 becomes equal to 4 times Ke1. Sometimes they will give you equal kinetic energy or equal momentum conditions. If you take the gun and bullet, this gun firing the bullet, what is same for both is mass is not equal, capital M, this is small m. Velocity also not equal, small u, capital VG, recoil velocity. What is constant for these two is momentum is constant. Kinetic energy momentum relation if you take, what is constant for both is P is same, but kinetic energy is not same. In that cases, what is the relation with the kinetic energy and mass of the objects is kinetic energy is inversely proportional to mass. In this case, P is constant condition you have taken. Kinetic energy inversely proportional to mass means which is having the more kinetic energy, they will ask you gun or bullet. Less mass, more kinetic energy. So bullet has more kinetic energy, so more harmful. More energy means more harmful automatically. Next is momentum is equal here. Sometimes they will give you two cars or car and lorry. Car and a truck. Automatically truck has a large mass than the car. Are moving with the, they are moving with the same kinetic energy they may give you. Same momentum is same as before. Same momentum is lesser body, less mass body has a more kinetic energy. But in case if we have that kinetic energy is the one which damages the vehicles when they are colliding, hitting each other's or accident timings. Next is if they are having the same kinetic energy, Ke2 equal to Ke1. Masses are not equal, means velocities are changed such that they have the equal kinetic energy. If they have the equal kinetic energy, then what about the momentum? Ka is constant. If kinetic energy is same, then this is same, P square is proportional to 2m it becomes, means P is proportional root of mass. Heavier body, more mass, more momentum. Truck has a more momentum than the car, but car, in this case you are taking the kinetic energy same. If the momentums comparison you are taking, if the momentums are same, then car has the more kinetic energy.